Hello, welcome to the video on partial fractions. This is our lesson part 2. Of course, if you haven't seen lesson part 1, you certainly want to start there and master that before you watch this lesson. Okay, so let's go and take a look at our objectives. So we're going to learn two methods to finish and solve the partial fraction problems. Okay, so these methods start after the rational function is written in proper decomposition form. So all of this right here was covered in lesson part 1. So after you understand what we did in lesson part 1, we're going to continue that process in this lesson so we can actually write the partial fraction. So obviously the concept here is pretty simple, but it is a very considerable amount of work to do these problems, and you really have to be, on your top level focus and really have strong algebra skills. So all the things that covered before in your past, you're going to have to call upon those. But I would have to say, as in anything, the number one thing that you really have to do is focus. I mean, really just as strong as you can when you're doing these problems, because one little tiny error can take you off, and you're going to be wasting a tremendous amount of time, or getting frustrated. So with that being said, let's go ahead and get into this. We got a good amount to cover here, and the example sets are significant, to say the least. So let's get into it, and let's just review kind of like what are we trying to do here with partial fractions, right? So it's a big topic, but let's not lose sight of the overall objective, okay? So basically, we're going to be given some sort of rational function, some sort of proper rational function. And the goal is to be able to write this rational function as the sum of simpler fractions, okay? So in this case, we have simpler fractions right here. So if you added up all of this right-hand side, you would get what's equal to the left-hand side. Now, what we want to do is find out what this right-hand side is equal to, or find out, actually determine this right-hand side. So you're just going to be given this is the problem, and we need to find out this. So what we talked about in the first part of the lesson part 1, was how to write the decomposition form, okay? So in this particular problem, this is the decomposition form. So in other words, we basically have a good format of what the answer is going to look like. So if you compare the actual answer to the form, you can see, okay, we got the denominators all correct. What we don't have is the numerators, right? We don't know what these values are, okay? So what B is 2 and C is 2. So our goal here, our objective in this part, lesson part 2, is to determine what these numerator variable values are. Okay, that is the key, because once you have those, we're going to replace the A, B, and C in this particular problem with -1, 2, and 2, and then we have our answer. Okay, so the way this is going to break out is the following. We're going to go over some general steps that you're going to do in any problem, and then I'm going to give you two methods, and you need to master both to finish out the problem. Okay, so let's go ahead and start with our general steps. Okay, so the general steps are the following. So you're going to write the partial fraction decomposition form. Basically, you're going to do what we covered in the lesson part 1. Okay. Now, once you got to that, what we need to do is write an equation. Okay, so we're going to have the rational function on one side and then a decomposition form on the other. So basically, that just means this. Okay, so we have our problem, the rational function, and the decomposition form, but it is very specifically written as an equation, one thing equal to the other. Now, the next thing you're going to do is you're going to clear all fractions of this particular equation by multiplying by the LCD. So we're going to take this whole thing and you're going to multiply by the LCD. All right. Now, once you're done with that, and I know I'm moving a little bit quick, so I would definitely encourage you to pause the video and take your notes, and probably even watch the video twice would be a good idea as well. But as you see these this process in action, these steps will make a lot more sense to you. But let's continue on. So after we multiplied this equation and cleared all the fractions in it, okay, we're going to use one or two methods. So we're going to use method 1 or method 2. They have names. I'm just calling them method 1 or 2 to find the values of the numerator variables. In other words, we're going to be finding the values of these guys right up here, okay? A, B, and C. And of course, this could be entirely, could be a whole range of things depending on the form that you're going to be writing. But basically what the numerator variables are, that's what we're going to be looking to solve for, okay? In this particular example, method 1 or method 2 will tell us that A is equal to -1, B is equal to 2, and C is equal to 2. And so we just plug in, we replace the A with -1. So if you notice, we'll get this. We'll replace the B with 2, and we'll get this. And we'll replace the C with 2, and we'll get this. All right. So instead of having a general decomposition form, we have the actual answer. Okay. So if I was to add up all of this here, okay, and that would be a little bit of work right there. But if I was to add up each of these guys together, it would equal to this. Okay. So that's the whole idea behind partial fractions. Okay. So let's get into it. This is the first method, method 1, but really I want you to know it as the equating coefficient method. And in the example set, I just kind of abbreviate that ECM. So equating coefficient method. Now what I'm going to do is actually do a problem, show you the method. I think this is the best way to see this, to kind of understand it, and then I'll give you some steps to remember, and then you can kind of watch this again, and obviously the example sets, the more you do that you'll understand it. So you kind of just stick with it until everything clicks with you. But let's get right to it. Okay, so equating coefficients method. So here's a problem. Let's suppose I got this rational function and I want to find the partial fractions to it. Okay, so what I'm going to do, step 1 is write the correct decomposition. Okay, so this is lesson part 1. We know that this is going to be equal to this. Just a quick review, okay, from lesson part 1. Remember, the most important thing, well, there's a couple most important things, but probably the number one thing that most students have to focus on is you have to first completely factor the denominator. Okay, so once that's completely factored, we're going to use the appropriate pattern. Okay, in this case, this is linear factors to write the general decomposition form. So that's what we have here. So this is going to be the case for all problems. Okay, we're just kind of keeping that general steps in mind. Now, in all problems that we're going to continue to do, or in this problem, we're going to continue to work this problem, but in all problems, we're going to take the LCD. Okay, now this is the LCD of this particular problem. If you need to review the LCDs of rational functions, there's a whole lesson on that. But this is the LCD right here. Okay, and we're going to multiply this LCD by this entire equation right here. Okay, well, we set this up. You can see that work right here. By the way, I'm not writing this in real time because there is a tremendous amount of writing that's going on in these problems, so I felt compelled just to keep the videos in a reasonable time period to pre-write everything. But all I'm doing here is I'm taking the LCD and I'm multiplying it by the equation. Okay, that's all I'm doing. So that's part of our general steps. So that's going to lead me to this point. Okay, here I cleared the fractions. Try not to look everything beneath this until I go over it. Okay, so this point here where we cleared the fractions, this is going to be the point where we're going to use either method 1 or method 2, but for every problem you're going to get to this point. Okay, so for everything beneath this, this is going to be specifically to the equating coefficients method. The next method we're going to be doing some different things. Okay, so what do we do? Well, let's look over here to the right. Notice here, okay, that I can distribute this A, right? And here I can distribute this B, all right? So I'm just using a distributive property, and I'm going to get this here, right? I'm going to get AX minus A plus BX plus 3B. All right, so really study this just to make sure you understand what's going on. So I'm starting to work on the decomposition side. I'm kind of cleaning things up. Now this is where students really need to understand this. Now we're going to combine like terms. Now think about this. I have an x term here, and I have an x term here. So a and b, just think of these as numbers, right? If I had 2x and this was like 4x, I would add the 2 and the 4, right? Same thing here, okay? So these are these are the x terms. So when I add these together, it's going to be a plus b x, right? So a and b x. Then what's left is just going to be our numbers, okay? Kind of think of those as numbers. So negative a plus 3b, okay? So that'll go right there. So this is the coefficient of the x term in a general sense, okay? And then this is just represents a number value. There's no x here. Make sure you understand that. All right, so if you get that, we can now equate coefficients. So let's look at the x term over here on the left-hand side. Notice its coefficient, the number in front of it, is a negative 2. Okay, negative 2 is in front of the x. What's in front of the x over here? A plus b. So this is an equation, okay? So we can equate the two. So negative 2 is equal to a plus b. This is the key to understanding this method. So if you just understood what I just said here, then you're going to be, you're going to be good with this method. Now, over here on the right-hand side, we have 3b minus a. It just represents a number. So that number here is 14, okay? There's no x's here, nothing like that. So 14 is going to be equal to 3b minus a. Okay, so if you got that, we're good. So this right here constructs a system of linear equations, all right? A basic 2x2 system. You probably remember this with using the substitution method or the combination method where you had x and y's. So, at this point in your math, skills, you certainly need to be able to understand how to solve a system. But hey, if you need to stop and go review because you're going to be solving a lot of systems in these problems, okay? So at this point, you should just go ahead and solve this system. Now, I show the work here, but maybe give yourself a little pop quiz. Make sure you can, solve this just as a quick review if you're a little bit rusty, okay? So here, I just use a substitution method to have a equals to minus b minus 2. I'm not going to spend a lot of time going here. You can see the work, okay, because this is basic algebra 1 type of skills here. But you can see all the work here to solve the system. And I get b equals 3, okay? So b equals 3. I can easily then solve for a. A equals negative 5, all right? So again, you can study this by, I felt compelled to at least write it out for you. So systems, you got to know how to solve 2x2 and 3x3. And in this, in some of the example sets, or there's one particular problem that we're going to be covering like a 4x4, but don't worry about that one. We'll get there. But you do need to know how to solve systems really well. Okay. So let's stop and take a deep breath here, okay? So I know that a is equal to negative 5 and b equals 3, but what does this represent? So remember, this problem here, we wrote our general decomposition form, okay? So when we did that, we used these variables a and b as a general form. What we're looking to find out is the actual values of those variables, and we just did that, right? So a is negative 5 and b is 3. So what we're going to do is basically rewrite this general form into the actual specific form, replacing the a with negative 5 and b with 3, and this is your answer. Okay, that's it. So if you were to add these two guys up here, you'd get this rational function. And that's it. Okay, so this is lesson part 1, essentially. All right, lesson part 1 gets you to be able to write the general form correctly. Part 2 of the lesson is to be able to determine these actual values. All right, so I'm going to give you some steps for the equating coefficient method, but obviously the best thing is just going to be practice and practice. Just stick with it, see how I do the problems, go back and review, and just keep working with it. But here's some steps that you can follow, all right? So the first thing, after clearing fractions, there'll be 2 polynomials on either side of the equation. So next, you're going to go to simplify the decomposition side by combining like terms. The coefficients will be the decomposition variables. So let me just scroll up and show you what that is. Okay, this is what we're talking about in step 2, using a distributive property and combining like terms over here. That's what step 2 means. And then step 3 is we're going to equate the coefficients of each expression on both sides of the equation. By doing this, you'll construct new equations. Often this is going to be a system. So what is meant by that is over here. Okay, so this is step 3, okay, of those instructions. And just so you know, you can pause the video, write things down, but I want to kind of show you so you have a good understanding of what the instructions or the steps mean. Okay, so once you have your system, okay, you're going to go and solve the equations from step 3, which is going to be the systems of equations, and then we're going to use those values to write our final partial fraction. Okay, so that is our first method. Okay, good. It's a good method, but it requires really astute, strong algebra skills. Well, all of this does, but that method in particular is even more demanding than method 2. I really like this method here. Method 2 is an excellent method, and it's the plug-in values method. Sometimes it's kind of referred to as a plug-in useful values method, and depending on maybe other textbooks, you might see these methods named a little bit differently, but they're describing the same thing. So I like to kind of abbreviate this as the plug-in values method, or the plug-in useful value methods, but that would be too big of an acronym. Okay, we're going to do the same problem. Okay, so again, we write our general decomposition form. Okay, hold on just one quick second. Double check. Yes, it is the same problem. I wanted to make sure that in fact it was. Okay, you can see this. There's a lot of stuff to cover, so I apologize if I'm going a little bit fast in the video, but just stick with it and certainly watch it again. All right, so we're going to do the same problem, but we're going to use a different method. Okay, so all the steps are going to stay. All the general steps are going to be the same, right? So we're going to write the decomposition form, the general form here. That's lesson part 1. We're going to multiply by the LCD, and then we're going to clear our fractions, okay? So at this point, we have negative 2x plus 14 equals all of this. So let's just go back up here real quick. And you can just see this is the same thing, right? Negative 14 plus, negative 2x plus 14 equals a times x minus 1 plus b times x plus 3. So just remember, when you get to this point, you're going to have to get to this point with all problems at this stage, and then you can branch off using one method. I'm not going to tell you what method to use in example sets, but you need to practice both, and we'll be doing that when we do the example sets. Okay, so just make sure you understand that for all problems, you're going to get to this point, and then you're going to branch off to the particular method. Okay, so we're at that point now. So here, we're going to go ahead and start the plug-in values method. Okay. What is this method about? Here, this method is great. Okay, I think you're going to like this method and probably prefer it during the problems. Let's look at what I highlighted here in yellow first before we continue on. Notice one thing. Okay, this is an equation, all right, and the only variable here is x. What that means is this: if I plug in a particular value for x here, let's just pick a value, it doesn't make a difference. If I plug in 10, 100, it doesn't make a difference. I can plug it in here, and I can replace all these x's with that number. The equation still holds true. In other words, the left will still equal to the right. Okay, so you need to kind of realize that from a mathematical standpoint that this equation is true for any value of x. Well, knowing that, we're going to replace this value of x with some actual number values, but they're going to be values that are going to help us solve for a and b, because that's what we're trying to do, right? We're trying to look for the values of a and b. So we want to be smart in doing so. Now, let me just say the following. The first thing that you want to do is create a zero, okay? A zero in these expressions. Now, what do I mean by that? Well, let's take a look at this guy here. A times x minus 1 plus b times x plus 3. The easiest way to create a 0 in this expression right here, okay, and we're really focused on the right-hand side, okay, the decomposition side, is to select a value for x that will 0 something out. Now, if I let x equal to 1, you can see here, and I'm going to replace all the x's with a 1. Actually, let's go ahead and continue on with step 2. So you can see here in step 2, I replace all the values of x with the 1. Now I didn't break the equation. I could put in anything. It's still going to hold true. But by using 1, by selecting 1, it's going to be very helpful to me because I'm going to get 1 minus 1 is 0. Okay? So let's kind of focus in a little bit better here. So I have a times 1 minus 1, which is going to be a times 0. So a times 0 is 0. That goes away. And that's just going to leave me with this one variable here. So let's just work it through. So by plugging in 1, I want to get negative 2 plus 14 equals a times 0 is 0 plus b times 1 plus 3, which is 4. So I can write that as 4b. When you simplify this down, okay, I'm going to get 12 equals 4b, which is a nice equation. And there you go. I have b equals 3. So we're already, already got this guy right here. That was pretty quick. And in comparison, let's just go up here to our previous work. We had to kind of get into a system. We had to do probably more work to get to that point in the problem. Okay. Now, like I said, this particular method is a very, very good method. All right, but you need to know both. Okay, so we have b is equal to 3. Well, you say, well, that was pretty direct. Let's use the method again, but this time let's figure out what a is. So we zeroed out the first time. We found a value to zero out this term. All right. Now let's do something to zero out this expression, this term over here. So what can I plug in to zero out this? Well, let's let x equals negative 3. You see that? Because a negative 3 plus 3 is going to make this 0. So then I'll just be left with the a. So let's go ahead and take a look at this. Now focus on the yellow line because that's where the x's are at. That's where I'm plugging in my negative 3. So I have 2 times negative 3 plus 14 equals a. Okay, now I'm putting in the negative 3 or wherever there's an x. Now at this point I want to show you something. You see this b right there? Let's erase that b actually. What you need to realize, and I should have had that written in advance, this now that we got that 3, that this was b, well, b is equal to 3, so we're going to actually write 3 there. Okay, but I wanted to show you that that is the b term, but we're going to write 3, okay, going forward. All right, but it doesn't make a difference because it's going to be 3 times negative 3 plus 3, which is 0. So 3 times 0 is 0. It goes away, but I want you to understand at this point we know what the value of b is. So you need to replace that going forward. Okay. So it zeroes out the b side, and let's just keep working this down. I get 6 plus 14 equals negative 4a plus 3 times 0 is just 0. So this gives me this nice equation here. 20 equals negative 4a. The a equals negative 5. Okay, so we have a b and we have our a values. So we have our 2 values that we need up here, right? And our general decomposition form. Now I just basically plug them in. Okay, I know a is negative 5 and b equals 3. Okay, we have our general form. I'm going to plug them in right here, and this is it. That's the answer. Okay. Now, if you're like a little, overwhelmed at this point, definitely, understand. You need to watch this video again. You need to really concentrate on what I'm saying. Okay. It is, there's so many details and so much focus required, but you're going to get this, really understand the lesson as best as possible, and then just jump into the example sets, even watch me do the problems, and then you try them on your own, okay, if that's what it takes. But this is going to require practice and practice and practice until you really kind of get the hang of it. So give yourself the patience and give yourself plenty of time. All right, so I'm going to give you some general steps now for the plugging in value method. So let's go ahead and take a look at those. So again, after clearing fractions, there'll be 2 polynomials on either side of the equation. So next, we're going to note that the equation from step 1, okay, holds true for any values of x. Okay, so we can plug in any values of x, it's going to keep the equation true. So as such, we want to use, we're going to plug in useful values of x that helps you solve for the decomposition variables, those a's, those b's, those c's. And then, as you'll see in future problems, you'll often get a system. In most of these problems, you're going to end up with a system in either method. Okay, so don't think that one method you're going to avoid systems. Sometimes you may, these are like more basic problems, but as the problems get more complex, you're almost always going to be facing a system. And then after we solve the equation from step 2, we're going to use those values to write our final partial fraction. So quite a bit of stuff. I understand, what you're going through, in terms of if you're like, wow, this is a lot. Remember, this topic was broken up into 2 lessons. It's a unique kind of topic, but extremely important, and one that you're going to get, one that you're going to master. Okay, but it does take effort and concentration. So let's go ahead and wrap this up, so we can get into those example set problems. So in review, all right. So in review, the first step in solving a partial fractions problem is to write the correct decomposition form. Now, again, if you didn't master lesson part 1, you're going to end up writing the wrong decomposition form, and so all the method and work that's going to follow from that is going to be wrong. Okay, so you make sure you don't even start this until you get that down. Okay, and that's going to require some real tremendous factoring skills and etc. All right, so after that, okay, next you're going to need to follow those general steps that we talked about by clearing all the fractions of the equation, and that would be that rational equation equaling that decomposition form. Actually, the rational function equaling that decomposition form. Okay, so you're going to get to, after you clear the fractions, remember at that stage you're going to go ahead and select one method or the other. Right, so you're going to select either the equating coefficients or the plug-in values method to find the values of the numerator variables. Okay, and this is almost always 99.9% of the time going to require you to solve a system. It could be a 2x2, it could be an easy system, it could be a challenging system. Okay, and then obviously you're going to finish the problem by writing the completed partial fraction. I want to say something before you get going on the example sets. I'm going to be doing like one problem using one method, the next problem I'm going to use another method. You don't have to follow that, and if you want to kind of do the opposite method what I'm doing, that's fine. But you need to know both of these methods, because one method might take you might sense that it's getting very complicated, and if you feel like, well, it's kind of getting out of control, if you will, you can stop and try the other method and go from there. There's a lot of work involved in both, but depending on what method you solve, some of the work can be really, really long versus just a lot of work. Okay, so just be smart and kind of test things out, and that's just kind of the nature of this type of level of mathematics. I wish it was more direct, but you do kind of just have to practice and struggle through it. So don't give up whatever you do, and keep working hard, and we'll see you soon.